Well, ladies and gentlemen, with this thought in place, we have for our first opening keynote, Business Implications of the Emerging AGI Revolution, Dr. Ben Goertzel, CEO and founder, SingularityNET Foundation, Hong Kong. Dr. Goertzel is one of the world's foremost experts in artificial general intelligence, a subfield of AI oriented towards creative thinking machines with general cognitive capabilities at human level and beyond. Thank you so much, Dr. Ben, for joining us, and welcome to the World AI Show. Over to you.
Yeah, thanks for having me. It's a pleasure to be back at the World AI Show again, and sort of update the community on all the cool things that have been going on in the world of AGI and decentralized AI. You know, every year talking about AI gets more and more exciting because there's just more and more amazing things happening in the field. So yeah, I'm gonna talk a bit about things that are going now in the AI field, and then share a bit about my vision for the future during the next year and a little bit beyond. I mean, I've been working on AI for 30 plus years as a researcher, and the last 20 years or so in industry. And certainly, you know, it's been revolutionary the last few years, the advances made in all sorts of different types of AI technology and across many different vertical markets. My thinking is, though, that we're in the middle now of the first of three distinct AI revolutions, each of which is going to be more amazing than the last. And we're now in the midst of what I would call a narrow AI revolution, where we have AIs that do highly specific things quite well, which then it takes a lot of human expertise to train the AI models and to integrate the AIs into your hardware software ecosystem. And we're going to hear a lot about that throughout this conference, which is all amazing and important stuff. I think the next step is going to be what I call the AGI revolution, where AIs verge more and more toward general intelligence. So the AIs more and more have the ability to think out of the box like people can, and to transfer their knowledge from one type of problem to another, to make abstractions and generalizations going beyond their particular training data. And then, you know, that's going to be a new AI revolution, and it's going to have AI being more autonomous and adaptive than it is now. And I think we're starting to see a bit of that. And what I want to talk about now is sort of the bridge between narrow AI and AGI, sort of systems that are getting more and more and more general intelligence as they go about carrying out the various domain-specific functions. And this, I think, is an important concept to understand, not just from a theoretical standpoint, but from a business standpoint, because as everyone's deploying AI, those who can faster and faster move in the direction of AGI are going to have a competitive advantage, and are going to be delivering more value and receiving more value. So yeah, I'm focusing on sort of narrow AGI, a bridge between narrow AI and AGI. I mean, after the AGI revolution, which we're just seeing the beginnings of now, we're going to move on to artificial superintelligence, which is another step beyond, which is AI's way smarter than people. I'm not going to focus much on that now, because this there's a limited time I have here, and I want to look more at near-term applications. But you know, this is out there and it's coming, and it's one of the reasons that it's important to get AGI right, because the AGIs that we build, they're going to grow out of our application-specific narrow AGI business applications. These AGIs that we build, they're going to be the breeding ground for the emergence of superintelligent. So if we want, you know, broad-minded, benevolent, democracy-oriented superintelligence, we want to be already directing our early-stage AGI systems in that sort of direction. So to give a clear vision of what I'm talking about, say in a smart city context, what we can do with narrow AI, we can use AI algorithms and models to carry out many particular functions within the smart cities, say traffic light regulation, automated driving, alerting someone when they may have a medical problem, operating the power grid in an adaptive way. But as it is now, these various smart or smart-ish functions are networked together within an overall, IT ecosystem that is not that smart. It's just a conventional IT system. And, a narrow AGI smart city would be an actual mind for the city where all the different functions within the city, there may be narrow AI models carrying out some of them, but they're coordinated together in an overall cognitive system that keeps in mind the goals and the state of the whole city, and then interconnects the narrow AIs concerned with particular functions in a way that works toward the overall well-being of the city. In the same way that each organ in our bodies has its own intelligence, but there's a coordination of the different organs in the body into an overall body intelligence. And in the biomedical domain, we can use AI now for diagnostics, we can use it for drug discovery, use it for imaging, a lot of amazing things. But again, it's siloed. These are all highly specific AI applications that a human operates and a human interconnects with other, pre-processing and result delivery tools. We're not able to connect together genomic AIs with clinical medicine AIs, with image processing AIs, with telemedicine systems into integrated systems where there's a coordinated whole. And, you could get there without yet being at the level of AIs that are like Mr. Data from Star Trek and really think with the full common sense world generality of an ordinary human being. And so, a sort of integrated mind for a smart city or an integrated mind for a biomedical research lab. These would be examples of narrow AGIs in these two particular vertical domains. And I think this sort of narrow AGI is probably how we're going to get from the current state where we have all these siloed off narrow AIs to the state of having full on human level AGI. Human level AGI could just pop out of some 16-year-old genius hacker's research project, right? But I think it's more likely it's going to emerge from the cross connection of a bunch of different commercially valuable narrow AGI initiatives, and then whoever is pushing forward these narrow AGI initiatives with success is going to have influence and some level of ownership over the AGI revolution as it unfolds. So, to get a little deeper in the cognitive science of it, you could view general intelligence as something that uses perception and memory to make predictions, predictions of the future, but including critically predictions of which actions will help achieve which goals. And, this sort of agent architecture of a goal-oriented agent that's using perception and memory to predict what to do action selection. This is how people work, it's how animals work. It's not really how narrow AI systems work right now, but it doesn't require full human level AGI to operate according to the general principles of a general intelligence. And the value of narrow AGI hasn't been articulated that much in those terms, but I think it's well understood. Why does Google drop a couple $1 billion on DeepMind? Why did Microsoft pay $1 billion for exclusive access of various sorts to OpenAI? It's not just that they want to foster benevolent AGI research for the long term. It's also that they see a value of this AGI-ish, AGI-oriented technology to help with a whole bunch of their business lines. So they're thinking about what I'm calling narrow AGI, although they're not calling it by that name. And I think when we dig into the details, to get much progress toward AGI, we're going to need to go beyond current deep neural networks. Deep neural nets are very cool. I was teaching them back in the 1980s before they were called deep neural nets, and it's amazing what you can do now with these technologies on modern hardware and modern scale data sets. But my feeling is that we're going to need to integrate a lot more threads that have been around in the AI field for a long time, from integrating symbolic reasoning with neural nets to get neural symbolic AI, integrating evolutionary learning and genetic algorithms for the creativity they can bring, and going beyond current forms of auto ML to real meta learning and meta inference with AIs that learn how to learn and improve their own reasoning and learning algorithms. And the integration of this broader scope of AI approaches, drawing on the full richness of the historical AI field, is going to lead to narrow AGI systems, which get their modicum of general intelligence by the synergetic interoperation of multiple different AI algorithms integrated together in a common framework. And one step in this direction is neural symbolic systems. So, I mean, we've done in my SingularityNET project, which I'll tell you a little more about in a few minutes. I mean, in SingularityNET, we've done some work in this regard, say for visual question answering. So you use neural nets to recognize low-level patterns in a picture. You use a symbolic system to reason about the relation between those elements in the picture. So I mean, if you ask how many cats are in the picture or something, I mean, the recognition of what's a cat and what isn't is done by a neural net. In this case, the counting is done by a symbolic system. And the advantage there is, like, if you have 13 cats in the picture and your training data contain no pictures with 13 cats, I mean, the symbolic system has a really easy time doing that generalization. For a neural system, you could do it, but you need a humongous training data set and a bit of luck to get to do that kind of generalization. So this is a case where doing some symbolic reasoning at one layer on top of what the neural net's doing at the lower layer is highly valuable and can improve understanding and question answering. And yeah, you see the same thing in language processing. I mean, we've seen GPT-3 has gotten a lot of headlines, and everyone was really excited it could generate, fluid human-seeming prose. Then after people dug a little deeper, they're like, wait a minute, but it has no idea what it's talking about, and the applications are kind of limited for something that's going to spew meaningless but meaningful looking nonsense like 10% or 20% of the time. Like, there's not many applications where you need an artificial bloviator that makes sense 80% of the time and not the rest. How do you get around that? Well, I think you're going to need a neural symbolic approach in some sense. You're going to need something that combines GPT-3's capability for syntax level pattern recognition with something that actually understands this semantic meaning inside the language. I mean, there's a number of ways to slice it. You can try to get the symbolic understanding to emerge from the neural system as is done in tree transformers, for example, or you could actually hybridize a logic engine from your neural net. But one way or the other, you're going neural symbolic. You're taking a reasoning type approach to AI combined with a scalable pattern recognition type approach to AI. And where you're talking about creative learning and design, I think, again, current neural nets are very cool at recognizing patterns and generating patterns similar to what's in the training data. But sometimes you got to be creative and out of the box and generate stuff that's not that similar to what's in the training data. And, even with things like learning to walk, it's been found that evolutionary learning is better than backpropagation and typical neural training methods. If you're trying to generate new forms of art, or say new scientific discoveries, new hypotheses regarding what's the cure for cancer, you need a fundamental creativity and ability to leap beyond the training data. And genetic algorithms do that. So this is a case where, neural nets have been poor at this. They tend to stick too closely to the training data, which is why you need to feed enormous amounts of training data to get them to do anything useful. In the case of transformer nets, CNNs, and other currently popular forms of neural net. But, genetic algorithms have been generating amazing works of art and behaviors for agents in simulation worlds for many decades. And so it's quite fascinating to see what you can do by combining the data modeling power of modern neural nets with the creative power of evolutionary algorithms. And I think this is going to be big both for algorithmically generated art and music, but also for, say, automatic hypothesis generation in the biomedical space. So the AIs can be helping to figure out the cures for diseases, and instead of just being sort of souped up next generation number crunchers to support human scientists as they figure out the cures for diseases. I mean, we may need some hardware advances to to drive all this. I mean, when you think about, say, episodic memory, the memory of our life history that drives so much of our metaphorical thinking. I mean, this is content addressable episodic memory. We think of something that happened, and then our mind comes up with every similar thing that ever happened. So there are hardware architectures that do this called content addressable memories. They're not that common, but I mean, now just as GPUs have become commonplace and have driven the deep neural net revolution, we may see content addressable memories driving an episodic memory revolution in AIs that remember their own experiences in history. We may see, graph cores on a chip, which can do highly scalable graph rewriting operations, drive the emergence of large-scale, highly capable logical inference systems. So the hardware and software have evolved in step in the deep neural net revolution, and we can expect that to continue to happen in the AGI revolution as well. And I mean, the integration of simulation with reasoning and with neural models is something else quite important. So, for example, I'm looking recently at some projects to do with AI for sustainability. We want to estimate from data from satellites and other kinds of imaging. We want to estimate the amount of carbon that's sequestered under the ground in various places. And, for that, it's a combination of machine learning predictive models, predicting carbon on the surface from satellite image. And then you have these ecosystem simulation models that let you predict how much carbon is sequestered under the ground from the plant cover on the ground. So these simulation engines, you can actually hyper-optimize them by training deep neural models to simulate the simulation engine. And then you're using neural symbolic machine learning together with a simulated simulation engine. Again, it's different AI paradigms, simulation, inference, and neural modeling, all working together to solve your problem with a level of generality that you don't get from a single AI algorithm, like a single deep neural net. And these examples, they illustrate the principle I call cognitive synergy, which is where multiple AI algorithms are cooperating together to solve problems, and they're being each other's best buddies. They're helping to fish each other out when they get stuck, because the problems that stymie a neural net are different than the ones that stymie a logic engine, which are different than the ones that stymie an evolutionary algorithm. So if they're integrated together in an appropriate architecture so they can help each other get out of the ruts they get in, that's how you get to general intelligence. And the OpenCog framework, this is an AGI architecture I've been working on for 12, 13 years, which is integrating together multiple different AI paradigms on a common in-RAM, weighted labeled hypergraph, an in-RAM distributed knowledge graph. We're now building a totally new version of OpenCog called Hyperon, which you can find out a bit about online on the OpenCog website. But I think you need architectures like this that are oriented toward integrating together many kinds of AI and a common body of knowledge. And we've been using this for controlling the Sophia robot. We've been using this for analyzing DNA of elderly people to understand what makes them live so long, and also for applications in fintech, smart cities, a whole bunch of other notions. And we're embedding this OpenCog AGI system inside a platform called SingularityNET, which you can find out about. Look at singularitynet.io. And I mean, SingularityNet, what it does is it lets multiple different AI agents, each of which it may be a neural net, it may be a reasoning engine, or it may be an OpenCog system that combines together multiple AI paradigms in a single system. We're having multiple AI agents embodying these different AI processes all communicate and coordinate together in a purely decentralized way with no single central controller underlying it. So using blockchain for this decentralized coordination. And I think this sort of thing is how the future is going to unfold. I mean, we're going to have systems like OpenCog that bring neural nets, evolutionary algorithms, symbolic reasoning, episodic memory together on a common knowledge graph. You're going to have systems like SingularityNet that allow a loosely cooperating society of AI minds embodying different AI approaches to work together to solve problems. And in this way, we'll get synergetic cooperation between different AI agents, or we're going to move from the narrow AI that's dominating industry today toward things like smart cities that are actually smart because there's an integrated brain controlling the whole city. Say, in the case of fintech, I mean, a current large investment bank, which has a heavy quant focus, they're going to have so many different machine learning models carrying out different kinds of prediction and risk management. But what nobody has is like an overall adaptive risk model that is coordinating, trading, prediction, risk management, hedging on every different scale based on understanding the whole state of the world. And so in smart city medicine, finance, any domain you can think of, a narrow AGI that can coordinate together the narrow AIs carrying specific functions is going to work better than a bunch of narrow AIs hooked together by humans and standard non-intelligent computer scripts. So I think my overall message here is, if you're working on applying AI to domain-specific problems, great, keep doing that. But think about transfer learning, think about generalization, think about integrating different AI algorithms or agents coming from different paradigms to get greater generalization ability than you can get from a single paradigm AI algorithm alone. Because a few years from now, if you don't think in this narrow AGI direction, you're going to be left behind by people building narrow AGI systems and plunging into the AGI revolution, just like people who haven't embraced narrow AI yet, which there's still plenty of, shockingly, are being left behind by those who are now deploying narrow AI systems. So yeah, if you want to find out more in any of these directions, SingularityNET.io has a bunch of information on SingularityNet platform. There's a opencog.org tells about opencog, and Singularity Studio is a commercial company some colleagues and I have founded, which is deploying these sorts of technologies to help large enterprises with their issues. And there's a website there too. So there's a bunch of information online about all this, which I'd encourage you to follow up. And I'm happy to engage with folks afterwards. Shoot me an email. We can talk about how narrow AGI may be applicable to the domains that you're working in. And I mean, needless to say, since this is an Asia event, this is a fully global pursuit, right? I mean, part of the beauty of integrating stuff from all different algorithms and all different types of AI systems is, people in different parts of the world and different industries are going to have different expertises, and we need to be combining these all together within societies of AI minds. So I think this sort of paradigm is ideal for leveraging emerging AI powerhouses like Singapore, Hong Kong, and so forth, as well as for the traditional AI centers like US West Coast. Thanks, everyone.
Thank you so much, Dr. Ben, for joining us. It was an absolute pleasure having you on the World AI Show. And thank you once again for being a part of this.
All right. Yeah, thanks for having me. I wish I was there face-to-face this time, but hopefully next year. So.
Absolutely. Thank you so much, Dr. Ben.